Hello, everyone, and welcome to today's webinar, Beginner's Guide to Building and Evaluating RAG Apps. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize weekly AI webinars. We do 2 per week, demoing data and AI use cases, new tools, and technologies. I post about our upcoming webinars every week, so if these topics are interesting to you, feel free to connect with me on LinkedIn to stay in the loop with our upcoming calendar. I'd also love to hear your feedback or ideas on topics that you'd love to see in our future sessions. Speaking of future sessions, if you click to the next slide, you'll see that on Monday, we are presenting Managing Hallucinations in Your LLM Apps. I know there's been a lot of horror stories lately about AI chat bots running amok. I saw one giving out a free car. I saw another offering therapy to an upset customer. So if you're interested in LLM apps but want to mitigate and monitor these risks, come join us to learn more about this topic. There's a link in the slide right there, hallucinations webinar, a QR code on your screen that you can take a photo or a screenshot of, and I'll put that link in the chat in a minute. Back to today's topic. You're welcome to participate in the discussion throughout the session. We have a Zoom Q&A button at the bottom of your console. We also have an internal mission statement to answer 100% of audience questions. That's getting increasingly tough as we have thousands of registrants to these webinars, including today, very popular topic today. And sometimes we get hundreds of questions that come in, but again, we will answer every single question. Even if we can't do it live during the session, we'll follow up with you via email, but you have to make sure to include your name and email address in your question. We won't be answering any anonymous questions. We'd also love for you to try out today's technology. In fact, anyone who tries it today during the session will be entered for a chance to win new AirPods Pro. Got the link on your screen there. It's that tiny URL, Build and Evaluate RAG raffle. There's a QR code on your screen as well. Very simple to be eligible. All you have to do is visit that link, log in. If you've got an existing trial account or an existing account or customer, you can just log into that account. Or if you've never tried it out, just create a free account. We've got a new free shared tier. So very simple to be eligible, and I'll announce that AirPods winner by the end of the session. Let me introduce our speakers today. First up, we have Srijan Kumar, the founder and CEO of Lighthouse AI, a no-code platform to evaluate hallucinations, security, and privacy risks in AI chatbots. We also have Ayush Pai, a computer science student at Georgia Tech, who we've partnered with regularly on projects that demonstrate the power of SingleStore for AI use cases. And finally, we have our very own Akmal Chowdhury, Senior Technical Evangelist at SingleStore and our resident expert on AI, machine learning, and data technologies. So I will turn it over to the experts here. Akmal, I believe you're up first. Take it away.
Thanks very much, Matt, and thank you to all of you for joining today. So as I always do at this time, check my clock, just gone 6 p.m. my time here in London. And so I'll just do a short introduction here. And because it's a packed program and Ayush and Srijan have got a lot to say, I'll try and keep my part as short as possible. And then I'll drop off and help with the Q&A. So just 2 quick slides on SingleStore. What is it? It is a database management system. That's how it started. But today, it's much more than that. We think of it much more as a data platform now because of its capabilities. And you'll be seeing more around this messaging in future webinars as they come along. Matt mentioned the free tier. Actually, I'll be partnering with one of my colleagues, Abby. We'll be doing a webinar. I think it's on the 26th, maybe next week sometime. Where we're going to go through this and show you how to get started. And it's going to be kind of like a beginner's guide to, how to get going on SingleStore DB, if you like. So an analog, a kind of a partner presentation to this one today. So originally, SingleStore, go back in time a couple of years, used to be known as MemSQL, both the product and the company, focused very much around OLTP and in-memory processing. Subsequently added columnar storage, the ability to do analytics at scale, and provide a single kind of storage mechanism, universal storage as a way to handle both types of data. So other products can do these kind of capabilities, but you have to kind of integrate them together. We are fairly unique in the market, and we do both using this universal storage, as it's called here, this single sort of table type. And so this slide is kind of nice because it shows the kind of 30,000-foot view, the high-level architectural view of this. And if we take a look at this, so we can ingest data at scale. Okay, and if you've been a regular and attended some of our previous webinars that we've done, myself, for example, I've in particular used Kafka quite a lot. And we have covered Spark in the past. And maybe, Matt, this is something that we should look at and revisit again, because I think it's been about a year since we last did Spark, and that would be a good integration to show as well. But we work very well with Spark as well, and other sources of external data as well, such as S3 and Hadoop HDFS. And the animation here, I think, is showing really the kind of ingest in parallel at scale. Okay, so we have this concept called pipelines, which really works well. Can take the data from these various sources and ingest them at scale. It is a cloud-based offering, and here you can see the three main cloud providers in the Western world: AWS, Google Cloud, Microsoft Azure, and it can be run on-prem as well. Okay, we have customers doing that, and there's a Docker container as well. But seriously, the quickest way to get started is to use the link that you saw for the AirPods Pro raffle. Click on that, use the QR code. It'll take you to a page to sign up if you haven't already done so. And then that will get you in, and you can start creating resources. Notebooks are there. There's a separation of storage and compute. There's a built-in SQL editor as well, and it's all cloud-based, and that's the nice thing. There is nothing to install locally. It's a really quick and easy way, low cost, well, no cost really for you, and no risk. So that is the best way that I would recommend to get going. The product itself supports a variety of data types. So yes, it has its roots in sort of relational technology. But we have covered in the past things like geospatial, for example, time series data. I did that not too long ago. We have the Lucene full text search engine built in. JSON support has been there for quite some time, and that's got even better with SingleStore Kai, which is now in GA. Okay, so that's for MongoDB compatibility. And so the product is both MySQL wire compatible and MongoDB wire compatible. Okay, so that gives you lots of scope. If you've worked with either of these two technologies, I mean, it is a very smooth transition to be able to move across to SingleStore. Real-time decisions, IoT dynamic experiences. We've covered some of these areas in the past. And last but not least, I mean, you can very easily create these real-time analytics. There is a notebook environment that's built in. So Python SQL code can be executed directly. You can create nice visualizations as well. I like Plotly Express, for example, is one of my favorites, but Matplotlib, any of the popular visualization tools that are available, you can use those. And also JDBC, ODBC. So if you use Tableau or similar tools, I mean, you can create these kind of dashboards. And again, if you're a regular, you know that I tend to use Metabase simply because it's just a jar file, the open source version, just download it. And within a couple of minutes, you can be creating some nice pie charts, bar graphs, and so on. Ad hoc queries are also possible using the built-in SQL editor. And that's really the easiest and quickest way to get started. And with that, I'll stop there and stop my share. Okay, so that's my part done. And I'll now hand over to Ayush and continue there. And I'll drop off, stop my video, and mute myself, but I'll be answering the Q&A. Okay, so if you have questions, I'll see you there in a moment.
Awesome. Thank you, Matt and Akmal, for that really great introduction. Good afternoon, everyone. My name is Ayush Pai again, and I'm current computer science student at Georgia Tech. And I'm really excited to dive into today's webinar where we really discuss how we can build and evaluate these RAG applications. Before we get into that, I really want to do a quick introduction to the technology at hand, right? And that technology is really large language models. And I'm sure up to this point, most of you have used something like ChatGPT or another LLM at one point or another, right? And at the core, LLMs are these colossal neural network architectures that are really pre-trained on a diverse and extensive data sets. They're built on the transformer model, which employs sophisticated mechanisms of like encoder, decoder, and enhanced self-attention capabilities. And these really allow it to discern, integrate patterns and data, and generate predictive text that can be remarkably coherent a lot of times and also contextually relevant, right? And however, like the problem with these LLMs is one significant issue, right? And this is called hallucinations. This is where a model might generate text that, while plausible, is kind of unfounded or incorrect. In a lot of cases, with a high level of confidence. And these hallucinations can range from like small inaccuracies to substantial misinformation. It can provide a really big hurdle in a practical application. As we progress into the realm of RAG-based applications, we can see how RAG can, mitigate some of these issues. While RAG introduces a retrieval component that can actually add to the generated process and enable the model to pull in relevant information while constructing these responses. And this really enhances the accuracy and reliability. But we can see how there's still some holes in the system, and that we'll kind of explore today. So continuing along the lines of these LLM hallucinations, right? So these are really instances when the model veers away from from the factual reporting, and it kind of leads to these three main errors that we see here, right? So the first is kind of the factual inaccuracies, and this is when the model kind of presents incorrect information as though it was true, and it kind of a lot of the time seems like it's true because they're presenting it in a lot of high confidence, right? And this could be something as minor as like, a wrong date or as major as like an incorrect like scientific claim. Next we get to, generated quotations or sources. Here's when the model kind of fabricates quotes or, attributes, information to non-existent sources. And this can be a significant issue when accuracy and credibility are kind of paramount in some of these systems that companies are building. The third type of issue kind of involves these logical inconsistencies, where the model kind of outputs are really internally contradictive or don't really align with the logical reasoning of the statement. It not only like, kind of affects the reliability of the information, but also the user's trust in the model, and ultimately the company employing the model. And addressing these challenges can kind of requires these robust mitigation strategies and enhancing the underlying architecture of the model is a primary step, improving the quality and diversity of the training data for the model as well. Incorporating, real-time information retrieval such as RAG can also, help in a lot of these cases for hallucinations. But this is a very, ripe area for research, right? There's a lot of ongoing work for, focusing on improving the robustness of the models and, decreasing those hallucinations. Um, so, retrieval augmented generation, I kind of mentioned the word RAG a little bit earlier. So what exactly is RAG, which stands for retrieval augmented generation? And this technology kind of really integrates the power of, generative power of these LLMs with a retrieval mechanism. So essentially what this means is, it allows the model to create, a curated database for relevant context before actually generating the response, which kind of like merges the vast knowledge that's encapsulated in these, very general, huge LLMs with the precision of, a database retrieval for, a specific task at hand. So the operational framework of RAG is kind of like a hybrid architecture where the input query is, first processed to identify, as you can see on this diagram here, the top K context from the database. These contexts kind of provide, the real world data and sources which the LLM can use to like inform its output. By grounding, these responses with, external information, RAG kind of really aims to bolster, the accuracy and minimize these hallucinations in a lot of cases by yielding responses that are not only probable but verifiable by, you can verify it by checking the data source that it pulled it from. But a lot of the times, the integration of retrieval mechanisms does not always make the model perfect, right? Um, the quality of the response is really contingent upon the accuracy and the relevance of the retrieved data. And also, the misinterpretation of this data by the model can, have inherent accuracies and can really, it can really lead to incorrect outputs and, hallucinations, even with RAG. Um, just continuing though on like kind of how RAG works before we move on, the retrieval step is kind of where it blends in the database efficiency and it kind of meets that with the sophistication of the large language models, right? So the documents are kind of transformed into these dense vector forms using embeddings that really encapsulate the semantic content of that specific, document. So the vectors are kind of stored in these places called vector databases, such as SingleStore which we'll be using in this demo. And it's kind of really renowned for its retrieval efficiency, which is really important when creating a system that needs to retrieve every time a user does a query. So when a query arrives, it's kind of it's similarly converted to a vector using the same embedding process. And a vector search is kind of executed against the database to identify documents whose vector representations kind of most closely match with that query vector. So this is kind of like a nuanced operation where it leverages like the geometry of these high dimensional spaces to kind of find matches based on like the semantic similarity. And this system like prioritizes documents based on these relevant scores, which we get from the similarity search, which are kind of like a function of the the vector similarity to the query itself. Um, and kind of like the most pertinent documents are then relayed to the large language model and provided as context and as additional information for it to generate its response. Continuing more on what the similarity search is, so this is what really makes it possible to match the user's query to contextually relevant responses for the LLM, right? So it kind of, it takes this mapping data such as, text into like this high dimensional space. And the high dimensional vector space. And these vectors are, a numerical representation, kind of encapsulating the semantic essence of the data itself. And by leveraging metrics such as, cosine similarity or Euclidean distance, there's a lot of different techniques you could use. But this system can really, discern the similarity between vectors and, how close two vectors are to each other, kind of effectively gauging, the semantic closeness of the two queries or two data points. And to really expedite these search processes, the similarity search, employs advanced indexing algorithms such as KNN, LSH, and these are really pivotal because they sort the high dimensional vectors in a manner that similar vectors, sorry, are kind of indexed in proximity, and then significantly enhanced search efficiency, kind of by diminishing the need for exhaustive scanning of the entire vector database. And additionally, like the complexity of these high dimensional data kind of needs these dimensionality reductions to really have like a practical computation time. In a lot of cases, we use something called principal component analysis (PCA) or TSNE, which are kind of like instrumental in distilling these vectors down to their most informative components, and it kind of really streamlines the search process instead of having these huge high dimensional vectors to search through. So now that we got through, what RAG is and how like the underlying technology works, we're going to be focusing on today's technology. And today's session, we're going to be developing and evaluating RAG chatbots, and we'll be using a suite of different cutting edge technologies of today. So firstly, LangChain will kind of pre-process and format the text data and really prepare it for the next stage where, the OpenAI embeddings will generate these vectorized representations that we were just talking about, right? So these embeddings are kind of then stored efficiently into SingleStore DB, which is effectively stores as or serves as a vector database. And for generating these responses, we'll have the option to either use Gemini or GPT-4, and you can use any other language model, but in these cases, we're going to be using these two models for today's demo as our large language model. And these will integrate into our user prompts with, retrieved context. And finally, our outputs will be, rigorously evaluated with Lighthouse AI's benchmarks and we'll assess the chatbot's performance. And we can also compare, different large language models against each other and see which one does the best in these situations. So starting off with LangChain, right? So the initial phase of the data pipeline is for our RAG model to really pre-process and get the data into our pipeline really in a way that the large language models can really understand and really create these documents that are really great for RAG. So LangChain really excels in the refining of text for NLP tasks. Really ensures that the input fed into our model is really optimized for these embedding generations that we'll be doing. It kind of begins with, if we're looking at the code here, right? This is just some simple code that's currently in our code base and which we'll all have access to. Matt should be sending out the GitHub link. But this essentially begins with this thing called the PyPDF loader, which essentially allows you to read and extract content from PDF files. This is crucial because a lot of times their data and tends to be in these sorts of documents. It's very easy to, just feed this PDF in and then create these documents out of that. And that's what LangChain really excels in, creating these documents and loading this data directly with PDFs, right? So once the content is extracted, LangChain kind of employs a sophisticated method called recursive character text splitter. And this tool really adapts, to the segments of the documents in chunks, right? So essentially what it does here is we have this parameter called chunk size, and it allows it to have, each chunk of these documents has 2,000 characters. And the segmentation is, carefully designed to avoid overlap, ensures the integrity of data is maintained, and these chunks really represent a balance between granularity and also like the context preservation, really essential for like high quality embeddings in a lot of cases. And this preparatory stage is really vital as it kind of lays the foundation for accurate embeddings that will be powering the model. The next step is the embedding generation itself, right? So this kind of involves, turning the text into a format that machines can interpret beyond just mere characters. It's turning into these high-dimensional vectors, right? Each vector is a numerical array where individual elements, um, or yeah, sorry, each vector is kind of a numerical array where these individual elements, floating point numbers, kind of represent the semantic, nuances of this text that we are talking about earlier. This vector representation is not just a random collection of numbers, it's a carefully structured encoding generated by this embeddings model. And every dimension kind of contributes to, the composite understanding of the text. And these embeddings, kind of are the cornerstone of the semantic understanding of a RAG model and kind of provide us with a robust foundation for creating these, retrievals and generation steps. So the next phase is kind of moving our RAG architecture into our vector database, right? And what we're going to be using here is SingleStore DB, which is a robust SQL database designed for high speed vector data operations in a lot of cases. And the connection to SingleStore DB, as we can see on the left corner here, allows us to leverage its high performance directly and store our query into these pre-generated store a query, these pre-generated embeddings, and with this method called SingleStore DB from documents, we can create a vector database which pairs these documents that we've have from LangChain with these respective embeddings that we get from OpenAI. This kind of pairing allows us to create this structured table, which is meticulously designed for swift retrieval, efficient storage, and really allows for the crucial handling of a lot of data in a lot of cases here. And the crux of the RAG functionality really lies in the query-based retrieval, right? Which is kind of like really adeptly handled by SingleStore DB's similarity search function directly integrated with LangChain. So when a query is issued, the system kind of performs a vector similarity search to find the most relevant documents. This process, relies on the embedding's ability to capture semantic meaning and allows the database to quickly return these documents with a high degree of relevance to the input query. And this setup not only streamlines, the retrieval of this important information, but also optimizes the RAGs model and allows it to generate accurate and contextually relevant responses by getting it from our SingleStore DB, which is serving as our vector database in this case. And this is kind of just a look of our notebook on SingleStore DB, right? We have on the left, we have the documents themselves in their raw format, and that's what's generated by LangChain. So that's one of these columns, and this next column is kind of the vector representations themselves. They may look like nothing, but they are, in fact, a lot of data kind of represented in this form that can actually represent how these different documents are related to one another, and really allows us to do these quick searches across the vector database. So the culmination of this whole RAG workflow is kind of the integration of a large language model where the user's query is, retrieved, where the user's query and the retrieved context from our, retrieval step kind of, combine to produce a coherent response, right? And in this instance, we kind of opt for Google Gemini Pro as our LLM of choice. But in the final code base, we actually have, ability to change between Gemini and OpenAI, and you can also add in any custom, any choice of your a large language model of your choice. But upon obtaining these relevant documents via SingleStore's similarity search, we kind of extract the context to really construct a prompt for the LLM. This is where the RAG model function kind of comes into play. So it kind of takes in this prompt, right? And it ensures that it cues to the LLM to generate a response that's not only accurate, but concise. So as you can see this prompt template here, we're kind of telling it, you're a helpful assistant who answers questions based on the context given to you. Keep the answer short. And at the bottom here was really what's important, right? We have the user query itself, which is fed in through this, this parameter in the RAG model. And then we also have the context, which is generated from this SingleStore vector DB similarity search method, which searches the vector database for relevant documents, puts it in this context, and then generates a response. I'll hand it over to Akmal now for our Lighthouse integration for evaluating these RAG chatbots.
Awesome. Thanks, Ayush. So let me get started. So, once you have created a RAG application, including the way that Ayush just mentioned, how do you then go about knowing whether the RAG application works fine or not, right? So that's where a lot of current techniques come in, where primarily people are creating these LLM applications and evaluating it in a very, very manual manner. That takes a lot of time because you have to label a lot of data. So we created Lighthouse, which is the first no-code AI platform that ensures quality of AI chatbots. It gives a scorecard that measures how well your system performs across these multiple dimensions, spanning hallucinations, out-of-context queries, toxicity, consistency and stability, as well as security and privacy issues like adversarial, prompt injection, PII data leaks, and more. So today, it's become very simple to create LLM applications, but it's become increasingly harder and more time-consuming to evaluate these LLM applications, including AI chatbots. So surveys show that developers and SMEs, SMEs means subject matter experts, they are spending 60% of their time in manually doing quality assurance and testing of their LLM applications. Estimates range from between 2 to 10 weeks when you're building enterprise-grade AI applications. And the worst part is that for every tiny change that you make in your application, let's say you change your prompt or the LLM or some system parameter or make some minor changes to the data, you have to repeat this entire process over and over again. And that's very expensive, both in terms of time as well as in terms of money. And in case you just skip the quality assurance step or do it in a sparse manner, you are really building these chatbots blindly. You can do some vibe checks and you can generate LLM applications. You can do some quality assurance in a very superficial manner, but that eventually leads you to a lot of risks, including legal risk, financial risk, and brand risk. So remember at the very beginning of the presentation, Matt mentioned that someone tricked chatbots into giving them cars for free. That's this case. People have tricked chatbots into saying toxic content. And very recently, hallucinations in chatbots were legally enforced in Canada when Air Canada's chatbot hallucinated a deal and a discount or rather a refund policy for one of their customers, and the courts essentially forced Air Canada to honor that chatbot hallucination. So quality assurance is really, really crucial when you are developing AI chatbot or other applications, LLM applications, when it's really crucial. So Lighthouse essentially helps you reduce that time, that manual evaluation time, so that developers and subject matter experts can focus on what matters most, which is building AI. And it does that in 3 different ways. First is this no-code test case generation suite, where we allow AI as well as subject matter experts to work in tandem in a loop to generate evaluation test cases. And we'll dive deep in this webinar on how to actually do this, how to generate these test cases. Once these test cases are generated, you get to the evaluation framework that helps you evaluate how well your RAG application, how well your LLM application is working in identifying quality, security, privacy, and other reliability issues in AI chatbots. And finally, once you have put things in production, you get to the point of evaluating the quality and ensuring that quality is maintained in real time. So through this end-to-end process, you can do a 360-degree quality assurance of AI chatbots. So let's get right to it. So the first step is generating test cases. So the way you do that on Lighthouse, and again, it's a no-code platform. So you log onto the dashboard and you upload the data. You upload the file on which you want to create the test cases. You select the relevant categories over here. In this case, since we are evaluating for RAG, we'll select hallucinations, but you have some other aspects, some other test categories as well. You can give it some seed test cases that you already may have created, and then you click generate a benchmark, right? So through this process, just a few clicks of buttons, you can generate a huge test suite, which is entirely customizable. We also have an SDK for those of you who love to code. We have the SDK using just 3 lines of code, which you see over here, using the benchmark generator.generate benchmark function. You can provide the data on which the evaluation needs to be created, the test cases need to be created. You provide the categories, the same set of categories over here. You can select a subset of those and generate a benchmark. And it takes a matter of minutes to generate that benchmark. And the benchmarks look like this. Specifically, when you're testing for hallucination, when you're testing RAG quality, hallucination is the most important thing that you're evaluating for. So the way it works is using the data that's uploaded, it generates these input-output pairs or query-response pairs, right? So it generates a query as well as an expected response and some additional metadata, such as the context from which it's generated and this file name, right? So you get a bunch of these queries, and you can easily customize. You can delete test cases. You can edit. You can say, I really like this one test case. So can I create, you can use the dashboard to create more test cases like this, right? So it's like just few clicks and you create a large scale data set that you can use for your evaluations. Okay. Next is to connect the application of the application that Ayush was describing earlier. The next step is to register or connect the application on the Lighthouse dashboard. So the way that works is, again, very simple form. You add a name to it. You select the type of whether it's a customer service chatbot, a RAG application, a non-RAG application, and so on. You add all that information in there, and you also have an option of providing an endpoint to it. So based on that, you provide all of this, and you can create, you connect the application to Lighthouse, so it knows what to query. This is the no code version, but again, we have the SDK. So for those, for you coders out there, you can register through app.register and you provide the same information. Just again, 3 lines of code, you register the application very easily. Okay, now to the fun part. Once you have connected the application, you get to evaluations, right? Because evaluating hallucination is critical over here. So the way Lighthouse allows you to do evaluation is in a two-pronged manner. This dual evaluation does it in a semantic manner as well as in syntactic manner. So in semantics, we look at a semantic gradation of quality of the generated response. So what's a generated response? So remember a couple of slides ago, I showed you that these are queries that are generated, that are created using the dashboard on Lighthouse. Now, the system that Ayush mentioned, the RAG system that you have created, now your goal is to evaluate whether the RAG system is correct or not. So how would you do that? Using the API and using the dashboard as well as the code, what you essentially do is to give each of these queries as input to the LLM to the RAG application and observe what's outputted. And since you already have an expected or a golden response, you can compare this golden response to the generated response. And then the Lighthouse evaluation toolkit gets to work. It does evaluation on a semantic gradation and says whether the generated responses are correct and complete, which means that it has information that's correct, as well as it has all the information that's present in the expected response. Whether it's correct but incomplete, which means there's some missing information. Correct plus extra information means there's some extra information. Then there's incorrect or hallucinated responses. And finally, oftentimes, RAG applications just fail to answer queries, so you get no responses. Along with that, we also give syntactic metrics like similarity score, which is the similarity, cosine similarity between the generated and the expected response, and the conciseness score, which measures the length between the generated and expected response. So this is the evaluation categories and criteria. The way you do that is essentially, again, 3 lines of code, evaluate RAG model, but you can also, and you essentially get a scorecard that looks like this, where you have, let's say you run some test cases, you get a score of what the pass rate is for your application. You can even look at the individual test cases and see, what the expected response was and what the generated response was, and you get the labels as well as the scores that I mentioned earlier. So you can see everything on the dashboard. And finally, and wrapping up here now, you can run multiple evaluations. Let's say you run it with GPT-4 as the LLM versus Gemini as the LLM. And you can see a side-by-side comparison of how well the system works. And it's interesting over here, both are really good systems, but at least in this one test case setting that we evaluated it on, you get like 50% accuracy using GPT-4, but 87.5% accuracy using Gemini, right? So using this function called evaluate multiple RAG models, you are able to do this side-by-side comparison. This is what the UI looks like. And yeah, you will need a Lighthouse API key to do that. So you can go to this website, lighthouse.ai/waitlist, and just fill this form. And in the form, just mention that you attended the SingleStore webinar, and we'll give you an account using which you can try the Lighthouse integration with SingleStore. I'll hand it back to Ayush for the code walkthrough.
Awesome, thank you.
You seem to be muted. Okay,
yeah.
Good.
So before we get into the code walkthrough, I think it'd be good to just kind of show like the Lighthouse dashboard, and definitely jump in, Srijan, anytime. But
Sure.
essentially, this is kind of the dashboard of Lighthouse. Essentially, you can see this is like the page where you land on, and you can see your apps, benchmarks, and tests, and the list of apps down here. And essentially where you can actually create the benchmark, which is kind of like the first step of this process, right? is you want to create your benchmark to evaluate your LLM RAG. So this is where you go. You can go if you want to do it within the UI. As this is called the auto bench. And this is where you can, upload your file that we were talking about, and then, check the categories that you want to use. You can enter your, test cases here, and then you can click generate benchmark. And then from here, you can actually see all of your generated benchmarks if you go down to this tab called benchmarks, right? So yeah. So I have, 4 of these benchmarks here. You can see like the results of, different cases I've used on this benchmark, and currently haven't run anything yet, but we can also see, the data that actually created in this benchmark here. So currently, for this example, right, I'm using the Super Bowl. And the reason why I'm using the Super Bowl for this specific use case is, it's something that happened a couple weeks ago at this point. And, large language models, they aren't up to date in terms of like, real time, right? They're trained at a specific point in time. And a big use case for RAG applications is when, these large language models are kind of behind on their context window on what they understand. I'm sure like GPT is trained back in 2023, same as, Gemini. So a lot of times RAG is used to actually, feed in information from real-time context. And the reason I'm using Super Bowl here is so we can check that out as well. So for this specific use case, it's generating these prompts for the Super Bowl. So what was the final score? Who led the San Francisco 49ers in scrimmage yards, etc. Generates these expected responses and also, cites the source content. Anything you want to add for this screen?
No, I think that's great.
Awesome. And down here, you can see all the apps that you have. And then for each app, you can see, the details, which includes, the benchmarks that you've run on them. And currently we haven't run any, but that's where we get into our demo. So here is our code base. And we've kind of showed, like, snippets throughout the presentation. But here's the entire code base, right? So it starts off, you import, the Streamlit. What we're using is Streamlit for our UI. Simple UI for, entering, the RagBot application and, doing these evaluations. We have all these LangChain integrations, and we have, integrating Lighthouse right here. So the first step is to load in the PDF. And we're using the LangChain library PyPDF loader to load in the specific PDF here. And, we put it into our data loader. And again, as I mentioned earlier, we kind of split these into chunks using this recursive character text splitter. And these texts are now our documents that we're going to be putting into SingleStore DB as our vector database, right? So these embeddings are being generated based on these documents because it's already into the text loader. And then we set up our SingleStore DB connection for our vector database. So this is your database URL, and this is where you create your SingleStore DB vector database, right? So essentially what you're doing is are using this from documents function to, you have 2 columns here. You have your documents, which is text, and you have the embeddings itself, which is all the vectors. And we're calling this table notebook. And here's where you initialize Lighthouse. So the API key, you have the benchmark ID, the Gemini app ID, and the GPT app ID. And these apps IDs can be created directly in the platform, as we kind of, Srijan kind of mentioned in the slides, or you can create them with the code. And I was creating it in the platform. So the way that you can do that is you can go to your list of apps. You can click on, create app. You can choose like what type of app you're using, enter the name, enter the endpoint if you're trying to use it directly from here, and then create the app. And once you create the app, you'll get this unique ID. So I have 2 different apps right now. I have one for Gemini and I have one for GPT-4. So I take both of those IDs and I put them into here so we can use them within this application. So here's like the modularized RAG model function, right? And this is kind of what we showed earlier in the presentation. So essentially it gets the documents relevant to the query. And it kind of essentially what it does is if there's no context found, it returns that there's no relevant information. But if it does find a document, it's going to be setting the document to the context to the first relevant response from the document. And this kind of it's going to be returning as many documents as it finds. But we're going to be using the first one as that'll be the most contextually relevant to our query. We have our prompt template, which is here. We kind of went over that earlier with the query and the context. And here's kind of a little bit new, which allows you to kind of change which model you're using, right? So if the model is Gemini Pro, we're going to be using, the LangChain Gemini integration here, and then returning the content from there. And if we're using, obviously, GPT-4, we're going to be using that as well as the prompt template integrating into there and invoking that method itself. And here are our two response functions, and I'll kind of show what those are used for. So essentially, once we have our chatbot method here, right? So we're using Streamlit, so we're just setting that up. We're actually creating, a radio button for choosing between the two the models, and so this is the user input, input field that's asking them to ask anything about the Super Bowl. If the user input field is entered, then essentially it's going to go through and create this response based on the RAG model. And that's simple enough. That's basically just using the RAG chatbot. But for actually evaluating the model, we have another button down here, which allows you to click on and evaluate the button. And essentially what's happening here is, right, you're initializing this evaluation. And this evaluation is directly integrated from the Lighthouse SDK. And you have this response function currently set to none because we're not sure which one we're going to use, right? And we're not sure which app ID we're going to use, because essentially when we're creating these evaluations, we need to there's kind of three parameters that we went over earlier as well. We have response function, we have benchmark ID, and we have app ID. These are kind of like the three parameters that we have. And based on if it's Gemini Pro or GPT-4, we're using the correct response function, correct app ID that we defined earlier, and then generating these evaluations. And then we can also compare GPT-4 and Gemini evaluations by generating multiple RAG models. And that's kind of this method right here. We're doing evaluate multiple RAG models. We have our three parameters here, and we're actually entering two app IDs here, and we're entering these two response functions. And yeah, let's test this out now. So we have our Streamlit UI here. And essentially what we have here is we can choose between these two different models. We can use Gemini Pro or GPT-4. And so let's use Gemini Pro first. So let's look at our document here and see what we can ask. Let's ask something specific and see if it's able to get it. So let's see. I'll ask about this guy, Christian McCaffrey. And so how was the spelling right? And yeah, so it seems to get some relevant information, based on this. And we can ask some other simple questions, right? We can just say, who won the 2024 Super Bowl? And again, what it's doing is, taking our query, searching the vector database for the relevant document. And this is kind of like a hallucination here, right? Gemini Pro says, not applicable. Let's see what GPT-4 does based on this this kind of query here. And it generates the right response. So, we're kind of feeding in the same prompt, but one model was able to outperform the other. Gemini Pro didn't find the right, it wasn't able to create the response, but we're feeding in the same prompt template. So it's not the issue of the document retrieval, it's the issue of the model itself. And that's where, it really comes into play, where you can, compare these GPT-4 and Gemini evaluations, or you can just generate the single one. So which one do you recommend I should do? Should I, run both of them?
Why don't you first show how to create the benchmark, because we haven't
Sure.
gone through that first yet,
Yeah, sure.
and then we can get to how you can evaluate it.
Sure, yeah. So you can go into the auto benchmark, right here. You could also do this within the code that we kind of showed earlier, but you upload the file. So currently we're working with a superbowl.pdf. And you select the benchmark categories that we're using here. So we're using the hallucination test because we're using the RAG chatbot. We click generate response, generate a benchmark, and you can also add, again, you can add these custom test cases. Um,
And then behind the scene, to add, so what's happening behind the scene is that our system, Lighthouse system, is taking the data that's uploaded, in this case, the superbowl.pdf, but you can also give other sort of information. It takes that information and it parses it through the Lighthouse system and does multiple steps to generate these prompt expected response pairs. A lot of candidates are generated and it goes through multiple filtering steps to get high quality generations, such as the ones that you see over here. But we also allow you to customize. So you see that button on the right. So Ayush, if you click that, the writing button on in each row. So you have the ability to edit the queries, expected responses. You can save. Once you edit, you can save, or you can delete queries that you don't like. And you can even say, this is a really good query and you can generate more, or this is a really good test and you can generate more tests like this. So in this case, Ayush just created a benchmark, which has, how many test cases were generated here?
I believe 8.
Okay, yeah. So eight test cases are generated. So let's see how well Gemini and GPT-4 perform over here.
Yeah, so what we're going to be doing is, running both of these evaluations. And you can see in our terminal, it's going to start evaluating on these 8 test cases. So first it's going to, evaluating I believe this is the Google Gemini one. So this will, take a little bit of time to run through these test cases. But do you want to, kind of explain like how it's, kind of
Sure.
matching in the back
Yeah.
end?
Yeah. So now again, what's happening, as I showed in the slide deck, was that for each query, we already have the generated responses, right? Or the expected responses, the golden responses. Now, each of these queries are being sent to the RAG system that has SingleStore as the database, as well as Gemini as the LLM. And each of these queries are being asked to that system. That generates a response. And now that response, the generated response, is compared both semantically as well as syntactically to the expected response. And remember, in one of the slides, I showed that the evaluation both is done semantically and syntactically, where the semantic evaluation categorizes the responses into categories like correct and complete, correct but incomplete, and so on. And then the syntactic evaluations do it for like conciseness score and similarity score. So all of that happens behind the scenes with just one click of button in this case. So Ayush, if you actually go to the dashboard and go to the benchmark that you created. So go to the benchmarks, yeah, over there. Yeah, and you can see that, in this case with Gemini, you get like 50% pass rate and 50% fail rate. And then you can see the individual test cases through which each of these things, each of the responses are passed. Right, and you can see interesting cases where, this row, the response just says not applicable, right? And the Lighthouse system is able to say that, it's able to categorize it as no answer, as well as give some semantic and other metrics, right? So you get some addition, some this gradation over here.
Yeah. And this will be really useful, for comparing, the expected response, generated responses. And then once we're able to get both of these evaluations done, now it's almost done with this GPT-4 one, we can actually go and compare, which one does better. And it can kind of show you like which LLM could be better for your specific use case in a lot of these cases. So it seems like it's done generating here. And it seems like it also got the same score, right? So let's see, it might have failed on different cases, right? So it seems like on this one it failed. There was a hallucination here. But now we can actually go and compare these directly, right? So how we'll do that is I believe we go to this specific benchmark here, view results, and we can see like the two evaluations that we kind of just had here, and we can kind of compare which one is better. In this case, they're kind of like the same. But then we can click on total here and we can see them kind of side by side, and the responses that one generated versus the other, and kind of see like how these compare. So this one was correct but incomplete. This one was correct and complete. And this one is an interesting case because both of them had no answers. So maybe it's an issue with the document itself. And you can kind of like look at these different test cases here, see how they differ, and understand how it's working in the back end.
Awesome. Yeah. I yeah, I think that's then yeah, thanks. That gives a very good overview of how to do the integration between SingleStore DB and Lighthouse.
Awesome. Srijan, you think we're ready for some Q&A before we wrap things up? Okay,
Absolutely.
awesome. We're definitely going to have to make use of the email follow-up because we have dozens of questions coming in. I wonder if we maybe have time for a handful before we get to the AirPods or raffle. So feel free to take a look at the list, and we'll maybe hand choose a couple favorites that are coming in. I think there's been a couple of questions, Srijan, about are these test cases predefined? What was the logic used here in creating test cases? Wonder if you could speak to that a little bit.
Yeah, so test cases are in these, you can have predefined test cases, you can upload those, and then you can augment it using the Lighthouse system. But the test cases that Ayush showed live, these are not predefined. It's generated based on the data that's provided, and you can give it any data, and it will use that as the ground truth to generate these test cases.
Good stuff. Ayush, I'll give you this one. There's been a couple questions about OpenAI versus Gemini, and I'm pretty sure you've done stuff with SingleStore using both our LLMs and embeddings created by multiple sources. So the question is, was this RAG model created by OpenAI or Gemini? And I wonder if you could just speak a little bit to your experience on using different providers.
So this specific embeddings was created by OpenAI. We're using the OpenAI embeddings, directly from the LangChain model. And I haven't used Gemini too much for embeddings. I'm not sure if they provide embeddings. I'm not sure if that's a thing, but definitely based on like the embeddings model that you use, you could definitely get different results. Definitely OpenAI, I think, is one of the best embedding models currently. And yeah, I think there's some other ones you can explore as well.
Awesome. Maybe one or two more before we announce the AirPods winner. Akmal, I know you've been furiously answering his questions as quickly as you can over there.
I think my fingers are bleeding there, Matt.
Is there any trends that you want to speak to based on questions or anything like that?
Yeah, so I think there's people kind of wondering what the role of a database system is in all of this. Why bother using a database system? Well, the main reason would be for kind of long-term memory. Okay, if you think about it, you store a lot of information up here. Okay, you got both short-term memory and long-term memory. So, for example, I can just about remember what I had for breakfast today, but I've got things that go back to my childhood, high school, university days as well. That's stuff that's in there, and I remember it really well. And so the database system serves that purpose. It gives you the opportunity to store these embeddings that you've spent money generating, probably, okay, although it's getting cheaper and there are open source alternatives. You put them in the database system and then you store them for the long term, along with the original data if you need to, and that gives you a way to query the data again and again. And then remember, a database system gives you all these wonderful properties, the atomicity, consistency, isolation, durability, all these things that allow multiple users to access the data and not step on each other's toes. So that's where the real benefit comes in. Okay, if you're going to work with this stuff at large scale, probably a database system is the best way to go.
Awesome. Srijan, I'll give you one last chance. I think we could do one more question, or if you see a trend of questions that you wanted to answer before we announce the AirPods winner. Anything you want to speak to, Srijan?
I've been answering questions just like Akmal when I got time. One question that was pretty common was like how to is essentially, once you do these evaluations, what are the different type of data that you can provide that's supported by both SingleStore as well as Lighthouse. As any sort of data, I believe it doesn't matter what sort of data can be inputted into the system to generate the benchmarks, to evaluate it, to put it in SingleStore DB. So I think it's pretty universal, both the systems that we have created.
Awesome. I think that's a good place to stop. So as I mentioned during the intro, we're going to be doing another webinar on Monday called Managing Hallucinations in Your LLM Apps. If that is an interesting topic to you, I assume it is based on what we've discussed here today, feel free to register. I just put the link in the chat. It's that tiny URL. Hope to see you there on Monday. The announcement you've been waiting for, today's AirPods goes to Sharon Sokoloff, a senior director of data at the New York Times. Congrats, Sharon. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of the day to someone who has tried out Srijan and Ayush's demo. We've put that GitHub in the chat a couple times. Feel free to try that out, and you will be eligible, I should say, for that raffle. And we'll also put that in the email that goes out in an hour or two. You'll get the webinar recording and that GitHub. Try it out. Awesome presentation and demo, Srijan, Ayush, and Akmal. Thank you to our audience as well for joining us today. Have a great rest of your day, everyone. Bye-bye.
Thanks, everyone.